Hello friends, in last class we have started with the module 3. Under that we have discussed about 2D clipping and clipping algorithms. We have seen two different clipping algorithms over there. One is point clipping and the second one is a general line clipping algorithm. Today we are going to see the second line clipping algorithm, that is Cohen and Sutherland line clipping algorithm. Now in this algorithm we are going to reduce the time required to find out the intersection points so that we can clip that particular line, and this time is reduced by performing number of tests before going for the intersection point calculation. And this algorithm going to use a technique of 4-digit code which is called as region code to indicate which of the 9 regions contains the endpoints of a particular line. It means we are going to find out the region where your endpoints of a particular lines present. Okay, now these region codes are assigned based on some conditions. Now this region code is going to be made up of 4 different bits: bit 1, bit 2, bit 3 and bit 4. The bit 1 is related to the left side of your clipping window, bit 2 is related to the right side, bit 3 is related to the bottom of your clipping window, and bit 4 is related to the top of a particular clipping window. Now the first bit is going to be set if the end point of a line is left of the clipping window. If your end point is at the left of the clipping window, this bit is going to be set to 1. The second bit is going to be set if the end point of a line is to the right of the window. At that point, this second bit is going to be set to 1. If the end point is at the below the clipping window, then the third bit is going to be set. And if the end point of a line is above the clipping window, then it is going to be set to the fourth bit is going to be set to the value 1. Otherwise the bit is going to be set to 0. Okay, now we'll see this in detail. Now see here. Now this is the center part is your clipping window. Now at the center point all 4 bits are set to 0. Now if you see the left middle part, now left middle part only the first bit is set to 1, remaining bits are 0. Right middle part only the second bit is set to 1. Top middle part only the last bit is set to 1, and bottom middle part only the third bit is set to 1. Now you take the diagonal or corner regions. Now this the first corner, that is top right corner. In this we have set 2 bits to 1, that is the left bit as well as the top bit. Similarly this top right corner we have set the right bit and top bit. Bottom left corner we have set the bottom bit and left bit. Bottom right corner we have set bottom bit as well as right bit. Okay, this is how the region codes are going to be assigned to the endpoints. Now we'll see how this algorithm works. Now the first step of this algorithm, assign a region code for 2 endpoints of a given line. Means for the 2 endpoints you have to find out the region codes. Now if both the endpoints have a region code as 0 0 0, means all 4 bits of a region codes are 0, that indicates that this particular line is within the clipping window, hence it is completely inside the clipping window, hence no need to clip the line. Okay, now the step 3, if the region codes are not 0, then you have to perform a logical AND operation for both the region codes. You have to take both endpoints region codes and you have to perform logical AND operation. Now if the result is not 0, then the given line is completely outside the clipping window. Means that the line is completely outside the clipping window hence you need to clip out that particular line. Else, if the result is not 0, means that particular line is partially inside the clipping window, means you have to find out the intersection point and you have to clip the portion of that particular line. Now for that you have to choose an endpoint of a line that is outside the given rectangle, that is outside the given clipping window. One endpoint which is outside the clipping window, that you have to choose, and find the intersection point of a rectangular boundary, means you have to find where that line is intersecting with your clipping window and replace that endpoint with the intersecting points and update the region code. And once you update the particular point of a line, no, the region code is going to be changed, hence you need to update the region code also. After that you have to repeat the step 2 until we find a clipped line. Okay, until the clip line is filled, you need to repeat the step number 2, and step 4 says that repeat step 1 for other lines. If the plane consists of n number of lines, for each line you have to apply this algorithm. This is how this algorithm works. Okay, in next video we will see an example on this clipping algorithm. Thank you.